Australia is one of the driest places on Earth. Yet, the country is trying to grow one of the thirstiest crops in the world: rice. On the surface, it sounds like a recipe for disaster. And indeed, that mistake has come with a heavy price. Farmlands are losing their nutrients, groundwater is drying up, and irrigation costs have skyrocketed. Agricultural regions that once fed entire communities are now on the verge of total collapse. It is the painful reality of a farming system that works against nature. But then, just when it seemed like there was no way out, Australia did something unbelievable. They moved nearly 1 million crayfish from rivers into rice fields and left them to live freely for an entire year. No constant monitoring, no cages, no immediate harvest. It sounded like a crazy gamble. But what happened next was incredible, and the final results left the scientific community stunned. The question is, what really happened on those rice fields? Before we dive in, are any of our viewers from Australia? Let us know in the comments by typing number 1. To understand why Australians would take such a risk, we have to look at the brutal reality of the continent. Australia is unlike anywhere else on Earth. The entire central region of the country is a massive furnace. The Murray-Darling Basin, considered the agricultural heart of the nation, provides food for millions but is facing an existential threat. During record droughts, water levels here have plummeted by 40 to 60%. Imagine this. Rice production, the pride of New South Wales, once dropped by 90% during the horrific drought between 2007 and 2009. Vast rice fields turned into dry, empty patches of dirt. The price of irrigation water soared, and the cost of running pumps and buying fertilizer became an unbearable burden. Even the toughest Australian farmers began to walk away from their land. But there is a darker truth that few people know. The lack of water is just the tip of the iceberg. The core problem lies deep underground. Australian soil has been weathered for millions of years without being replenished. It was already nutrient poor, and now it has been drained dry by industrial farming. The soil has lost its soul, and that is when the real disaster begins. There is a term that every Australian farmer fears: salinity. Why is the soil so salty? The reason lies in geology. Australia is an ancient continent without volcanic activity to recharge the soil with fresh minerals. For thousands of years, native plants with roots reaching dozens of feet deep acted like natural pumps, keeping the salty groundwater deep below the surface. But when humans arrived, they cleared the native trees to plant wheat and rice, which have very short roots. Without deep roots to hold it back, the groundwater began to rise. The tragedy is that Australian groundwater contains massive amounts of salt accumulated over millions of years. As the water rises, it brings the salt to the surface. When the water evaporates under the scorching sun, the salt stays behind, forming a white crust that looks like snow but signals the end for all crops. Today, over 5 million acres of land in Australia are severely degraded. In Western Australia, about 8% of agricultural land has been completely destroyed by salt. Once fertile regions are now abandoned, turning into white graveyards. In this context of dead soil and dry water, a big question arose. Why would anyone think of putting crayfish, an aquatic creature, into these dying lands? Could they even survive? Or was this just a final act of desperation? This was not a random decision. Before turning to crayfish, Australians tried everything. They poured billions of dollars into smart irrigation systems and used the most expensive chemical fertilizers and pesticides. But every path led to a dead end. The more chemical fertilizer they used, the more the soil structure broke down. Beneficial microorganisms died off, making the soil lifeless. Production costs went through the roof while crop prices remained unstable, leaving farmers in deep debt. In many key regions, rice acreage was cut by 70 to 90%. At that time, agricultural summits were actually discussing a dark scenario, ending rice farming in Australia altogether to save water. It seemed like the most logical solution. However, in that darkest hour, scientists had a bold idea. We cannot use chemicals to fix a broken biological system. We need a biological solution. And that is when our main character stepped onto the stage. The creature chosen for this mission was not a foreign invader. It was the redclaw crayfish, a species native to Australia. Unlike the invasive crawfish found in other countries, the redclaw is a true warrior of the outback. They are incredibly hardy. They eat almost anything. And most importantly, they have an amazing ability to survive in low oxygen water and high temperatures. Why was the redclaw the key? First, because they are native. They do not cause ecological disasters or destroy banks and levees like invasive species do. Second, their burrowing habit is a gift to the soil. These burrows allow air to reach deep into the ground, improving water retention and soil health. Scientists realized that the redclaw was not just a product to be sold for money. They were free biological machines, working 24/7 to restructure the compacted and salty Australian soil. Moving 1 million crayfish into rice fields was not as simple as opening a cage and letting them go. It was a precise technical process. Australian farmers use two main models. The first is co-culture, where rice and crayfish live together. While the rice grows, the crayfish clean up weeds and pests. The second is rotational farming, which is more common. After the rice is harvested, instead of letting the field stay dry during the off-season, they pump in a small amount of water and release the crayfish. To prepare for this migration, the rice fields had to be redesigned. Deep trenches were dug around the fields to provide a cool sanctuary for the crayfish when surface temperatures got too high. The water pH was strictly controlled between 6.5 and 8.0. And here is the most important part. Once the crayfish are released, all use of pesticides or chemical fertilizers must stop completely. Even a small amount of chemicals could wipe out the entire army. The stocking density was carefully calculated at about 2 to 4 crayfish per square yard. Across the entire region, that number quickly reached the 1 million mark. Many people were skeptical, asking if they would eat all the rice shoots. The answer was no. Farmers timed the release and managed water levels perfectly to ensure the crayfish only ate plant debris and weeds without touching the growing rice. As the million red nights settled in, a miracle happened beneath the mud. First, the soil structure changed. The burrowing created a massive aeration network. Oxygen traveled deep into the dirt, bringing beneficial microbes back to life. As a result, rice roots grew stronger and deeper to find nutrients. Second, crayfish are dedicated cleaners. They eat algae, weeds, and decaying plants that usually produce toxic methane gas. Then, they return nitrogen, phosphorus, and carbon to the soil through their waste. This is the perfect organic fertilizer, absorbed directly by the rice roots. Research at pilot farms in Queensland showed shocking numbers. Soil water retention increased by 18%. Surface water evaporation dropped by 10 to 30%, thanks to the constantly stirred mud. Soil fertility recovered visibly after just one season. In lands once considered dead due to salt, the rice began to turn green again. The presence of the crayfish diluted the salt concentration at the surface, pushing it deeper or dissolving it into the circulating water system. The economic results were even more impressive. Data from local agricultural associations show that rice yields in fields with crayfish increased by an average of 9.5%. How did the yield increase when some land was taken up by trenches? It is because every stalk of rice was healthier, the grains were fuller, and there were fewer pests. But the real game changer was the double income. During severe drought years when rice production might drop, farmers still had a very stable income from selling crayfish meat. Look at the math. On about 2.5 acres of land, this combined model brings in $6,000 to $6,500 more profit than growing rice alone. Redclaw crayfish are a premium product, highly sought after in luxury restaurants. Now, instead of just relying on rice, Australian farmers have a solid financial cushion. As they say in the Murray-Darling region, even if the rice crop fails, we still have crayfish to sell. Of course, Australia was not the first to think of raising crayfish in rice fields. China has been a leader in this since the early 2000s and has expanded across millions of acres. However, there is a vital difference between the two models. China uses the Louisiana crawfish, an invasive species that is hardy but risky. Overfarming in China has sometimes led to water pollution from leftover feed and damage to levees because the American species burrows too deep. In contrast, Australia uses its own native redclaw. This ensures perfect ecological balance. They do not destroy infrastructure like their American cousins, and are perfectly compatible with the local environment. Australia took inspiration from China, but upgraded it into a more sustainable and environmentally safe version. Even though this sounds like a fairy tale, it is not without risk. Farming is never easy, especially when working with living creatures. First, if the crayfish grow too large or the population becomes too dense without enough organic food, they might turn and attack the rice roots. This is a disaster if farmers lose control of the numbers. Second is the environment. Although redclaws are tough, if water temperatures stay above 95 degrees Fahrenheit for too long, they will stop breeding and could die in large numbers. An imbalance in water pH is also a silent killer. Farmers must become true biologists. They have to check the water every day, monitor the behavior of the crayfish, and adjust irrigation with extreme precision. Do you think these risks are worth it to save lands that are dying from salt and drought? Comment yes or no. In the long run, the rice and crayfish system is not just an economic model, it is a solution for climate change. Removing chemical fertilizers significantly reduces greenhouse gas emissions. At the same time, increasing organic carbon in the soil turns rice fields into natural carbon sinks. Furthermore, this model creates a diverse wetland ecosystem. Birds, beneficial insects, and other aquatic species are starting to return. The rice field is no longer just a lonely factory for starch. It is a living, breathing entity. In the era of climate change, where droughts will become more frequent and severe, the rice and crayfish model is seen as a natural drought defense. It helps keep moisture in the soil longer and makes the most of every drop of rain. Sometimes, the best solution is not a billion-dollar water filter or complex gene editing, but a tiny creature living in the mud. Currently, the migration of 1 million crayfish is mostly happening in large-scale pilot projects and pioneer farms. But the wave is spreading. The Australian government, top universities, and indigenous communities are actively expanding these trials. Legal and technical barriers are being removed. Moreover, the export market for crayfish is growing fast in Asia and Europe, creating an undeniable financial incentive. Experts predict that within the next 5 to 10 years, rice and crayfish farming will no longer be a shocking experiment. It will become a new industry, completely redefining sustainable agriculture in the land down under. One million crayfish have been released, and millions more are following. This is not just a scientific experiment. It is a powerful shift in how humans learn to live in harmony with nature instead of trying to conquer it. The story of the red knights in the Australian rice fields leaves us with a big question. Is this a brilliant breakthrough, or just a risky gamble we are forced to take because we have no other choice? In a world torn between high technology and a return to the laws of nature, where would you put your faith? Leave your thoughts in the comments below. Do not forget to like this video if you found it helpful, and subscribe so you do not miss our next incredible agricultural journeys. Thank you for watching.